solving ZFS problems here in this video. ZFS problems caused by drive failure, or if you want to expand ZFS, or if you want to shrink and reconfigure ZFS, then you should know what you're doing, especially if ZFS is also being used as a boot drive. I'm now here on my Monster PVE, my self-built homelab server. People who have been watching for a while will know it. The series I made about it, here from the 90s junk pile, turning it into a really awesome Proxmox machine. This Proxmox is now running here, and the system drive is a ZFS mirror. So that is how I installed this Proxmox here, and this ZFS mirror works great. I'll go to the disks and show you that right now. Take a look right here. We have the Micron, the SDF, and another Micron, the SDE. That is the primary system drive where the EFI is located and where the boot partition is. Additionally, there is a ZFS drive sitting on partition number 3, and it is working quite well. What I'm going to do now is simulate a drive failure right here. Yeah, that's a bit clearer. SD and SDF are my system drive. That's where box boots from. That's where it starts up. And that's also where the ZFS runs as a mirror. Then you go here from disk to ZFS and show this mirror. Now this is the pool. Usually the operating system pool is created when you install it. The pool, that's what the pool is called. And here is my mirror. My mirror consists of 1 Micron, which is plugged into an NVMe slot, but it's actually a SATA drive, and a second Micron SATA SSD, which is also plugged into an NVMe slot. The mirror works regardless of which of the 2 disks fails here. The box server would still start up normally because both disks contain the same data here. What I'm going to do for you now is simulate the failure of one of these disks. That means I'm going to shut down this Proxmox, remove 1 disk, and then start Proxmox again. And when that's done, we'll meet back here in a moment. I'm shutting down now. My ZFS is running properly. There's no reason to do anything here right now. We just have to go back in there for a moment. We can see that it's online and that the health is fine. So the health status up here is fine. There's no reason to worry here. You should also regularly check the disks and look at the smart values. You can also make this available in the AI however you like, or you can immediately see here if any massive numerical values are showing up. Then you should investigate that. Otherwise, I can't explain every single value here for hours on end. Still, you should regularly check the smart values to see if the hard drives are healthy. You can also go over here and see how worn out they already are. This one is at 3% and that one at 4%. That means they'll keep running for a while. Always keep an eye on the health of your hard drives, please. So I can see here now that the pool is fine. I'm going to shut down the server now, pull out a disk, and then the pool will no longer be fine. And we'll pretend as if a hard drive failed during operation, as if it broke. And then we'll notice it here. So first I'll turn the thing off, shut it down properly. And when it starts spinning here, it's off. And then I'll pause the video and be right back. Now a drive has failed. This is now symbolized by me simply removing it. Now a drive has failed, and as an admin you can see it. Of course, I check regularly, look at the smart values regularly, and have noticed it. My pool is broken, a hard drive is broken, it needs to be replaced, and the pool needs to be repaired. The ZFS pool needs to be repaired so that my redundancy is restored, and I really don't feel like reinstalling everything. That's also the really great advantage of using these ZFS pools, that I can easily go ahead and remove the broken one now, and then proceed to mirror the pool onto this new NVMe. And with that, I've migrated the operating system without having to reinstall it. Let's just assume for now that a hard drive is completely broken and the computer is already open. And now, of course, I can also remove the drives, but first I have to shut the system down. Disconnect the power, because one SATA SSD is above the graphics card and one is below it. And if I start unscrewing things while it's running, the component could fall off. I could also unscrew the graphics card and cause short circuits as a result. So now the thing is being shut down. I can also just press here and then it will shut down. And once that's done, the power will be disconnected. And then I can easily take out the drive here. Just carefully shift the lamps aside for now. Of course, it naturally takes a little bit of a moment because there are also VMs running on the device and you just have to give it a few more seconds to finish. So now it's off. I'll switch it, turn off the power supply and carefully pull out the power plug. I can't just let it dangle somewhere. I'll let it dangle here. I'll also unplug the other cables and let them all dangle here. So now I can already remove the first SATA SSD here. So here's what I've done now. My Proxmox behind me is running, but it's not accessible. That is the very first major complication that can occur when a hard drive connected to a high-speed PCI Express expansion slot fails. I identified this defective, failed hard drive and physically removed it from the server. And now, unfortunately, I can no longer gain access to the data on this server. What happened? After I carefully removed the SATA-based solid-state drive from the dedicated PCI Express NVMe expansion slot, I noticed that internally, the internal PCI bus numbering system had automatically reconfigured itself. That means in this case here, for me, it's the case that the network card has now received a different number internally in Proxmox. It's no longer ENP6S0. Instead, it has become ENP7S0. In other words, if I suddenly remove a drive, then with high probability, if it's a PCI connection, the PCI numbering will change. You absolutely have to remember that. Now, I actually have to go to the Proxmox itself back there. It has its own graphics card and there's a monitor connected to it. Now I can log into the shell there and access my interfaces. I can enter the new PCI Express, that is the new numbering of the network card. Enter it. If I type in IPA, it shows me which network cards are present and whether they are up or down. So now, over there in my shell, I enter IPA and then I can see what numbering this network card has now received. And then I go into nano, etc. network interfaces and enter the new number there. And then I immediately have a connection again. So that is how I did it for now. What I want to do is simulate a faulty drive, but I don't actually want to break or delete the drive while leaving it plugged in. So I just pulled it out instead. By pulling out the drive, my PCI numbering changed internally. And it automatically assigned a unique ID number specifically to the network card here. And therefore, the number that's in the interfaces file, I'll go in here, no longer matched. Interfaces. And now for me, the network card is listed as ENP6S0. If I now plug in an NVMe or anything else, any other, if you plug a standard PCI Express device into this slot, then this specific number right here will become a 7. In my case, it's a 7, but you might not have the same anomaly or the same numbering. For me, it automatically becomes a 7, and if I type IPA, it clearly shows me all of the interfaces here. And for me, the 6S0 model is the network interface card that provides my internet connection here. And if I really do plug an SSD into the PCI Express port, then internally it will become 7S0. And then I won't have any network access anymore. I need to know that. That has to be clear, right? I have to expect that such shifts can happen within the drive or component numbering or the device numbering. So always keep that in mind. It is an important point to remember. Now, here I am on this PvP monster. The hard drive has unfortunately failed at this point. I either received a notification by email or during my routine check of such a server, I noticed that there are some significant issues here when I look at ZFS. Right away, oh, degraded. It was downgraded from a mirror to a single drive, basically. And now I go into the disks and check, is something missing here? I see here is the SDE. Well, now where did the SDF go? That's my second drive. It's missing, so now I have a rough idea. Here's a problem. I'll check ZFS again. My rpool is degraded. Double click, let's see. Well, now Annuel, not available. Where is the disk? What happened to it? I have, of course, expanded upon them here in my case. Yes, however, it could also simply have been blown through internally on the server. The connection is simply gone. Either the drive is broken, the controller is broken, or something else is wrong. I know for sure that the disk is gone, that it's no longer there. Here's what I did. I removed the disk, spent hours working on it, screwing around with it, plugging it in again and again, cleaning the contacts, doing everything I could. And it still says here, no, the disk is not there. Even the BIOS says, no, the disk is not there, nothing is plugged in. So for now, I'm assuming that the disk itself is broken and not the controller. Then, just to be sure, I plug the disk into the test computer and realize, oh, the disk doesn't work, it's broken, it's done for. What do? I march over to the old man and say, I need 300 euros, I have to buy a new disk. What does the old man do? Oh, why, how come, what's the reason? Why doesn't it work like that? Then I say, no, it doesn't work like that. If this thing fails, then you won't have any computer at all. Yeah, but why? Why? He complains about it, the old man, but gives you the 300 euros. And you buy a new disk. So now I've bought a new disk and realize, okay, I have to shut down the server, let everyone know not to work on it anymore, stop all services, shut down the server, and start installing the disk. Of course, I've now bought an NVMe, planning to switch from SATA to NVMe right away. That works too. In this section, you can easily add several different drives to the storage pool right here. And furthermore, you can also create a new pool from various drive technologies or different drive sizes, pretty much however you would like to set it up. Just keep in mind that the new drive should be at least slightly larger than this one we have here. This is a 256 gigabyte SATA disk, so the new drive for this pool also needs to be at least 256 gigabytes in size. It's better if it's 512 gigabytes, because sometimes due to the calculations and these 1024 bytes, and all these calculations and various metadata and reserved areas on such a disk are not always the same. And if the disk is larger than the target drive that I then install as a replacement, there can be significant technical complications mirroring this storage, this mirror onto it. So either use an identical model where it's virtually certain and guaranteed to fit, or a slightly larger model would be a much safer and more reliable choice. I have here now, I got myself a 256 GB NVMe. I had already tested this beforehand. It works. It fits to mirror onto it. And now I will install it and rebuild this mirror with the 256 gigabyte NVMe. I've written a comprehensive article about this entire process of adding, removing, replacing, attaching, and detaching. I have it here on my website, Proxmox ZFS, what to do if an SSD fails. And here I have like this, the commands, the explanations, and I tried to include the most important things in this article. This is tailored to my Proxmox server here, and I kept changing the order, because the order is actually important for how you go about it here. And this guide works quite well, and I'm going to use it here in this video. Yes, so that it's certain that this works. Still, you can't just do this casually on the side. You really need to have some understanding of how ZFS works. And that's why I'm going through the whole thing step by step here in the video. Feel free to rewind and fast forward as needed to see how to fix it. And now I've realized my ZFS is broken, and I'm asking myself, how do I repair my broken ZFS? And that's what I'm going to do here now. I have to shut down the server to install the new NVMe. I'm going to do that now. So my server is back up, but now I had the same problem again that I already had earlier. After I plugged in a new NVMe disk, I noticed that it automatically changed the PCI Express numbering, and my network card changed from NP6S0 to NP7S0. Since NP7S0 was no longer listed anywhere in the interfaces file, I manually updated all the relevant entries to fix it. In the interfaces file, I changed it to 7S0. And now my Proxmox has an active internet connection again. I can access the interface again now. Always remember, when you plug in or remove PCI devices, the assigned names or numbering of other devices may change. So, to make things a bit easier, I have an explanation here, and now we'll go through the commands from top to bottom. Now I have the new NVMe disk here. Disk, up here is the NVMe disk, and since it's plugged into a PCI Express slot, yes, it shifted my network card, and that I had to adjust that, which I did in the nano, etc. network interfaces file, and now the box is running. Now I want all the data from the SD to be transferred to the NVMe 0 in 1. I can't just do that with the replay command, because the replay command would only copy this ZFS drive. So first I have to initialize the partition table and the partition here. And that's absolutely essential for a system drive. Otherwise, Proxmox wouldn't be able to boot from it. With any other ZFS pool, you can skip this step, but not with the system drive. I've also written all of this down again. SG disk creates on the target, in my case, that's the NVMe 0N1, the same partition or the same partitioning, the complete partitioning, as it is found on SDE. It will be created exactly the same way. The 3 partitions that are currently there will be created in the same positions. I'm using this command. sgdisk-r equals dev NVMe 0N1 space dev SDE. I apply the same partitioning on this drive as I did on that drive. That is what this command is for. Just make sure that your devices are entered here and that they are the correct devices. Here it is again. The target drive is here in the command. The source drive comes after it. So I'll go into the shell here and paste in the command. Of course, these commands fit my system. My disk is the SDE, that's the source, and the NVMe is the target. And now I'm going to apply the partitioning you find on SDE onto it. Done, the operation has been carried out. Now I'll take a look in here, do a reload, and bam, there are the 3 partitions. They were created exactly as you can find them here. Boot and EFI are empty, so I have to initialize this whole thing there. And these partitions also need their own GPT ID. It says here the command generates a new unique ID, so that's what it should do. sgdisk-g dev and my target drive NVMe 0N1, make sure that it's the correct drive in your case, and insert action. The operation has been executed. What I still need now is for partition number 2 on the NVMe disk to be formatted accordingly, so that it basically becomes an EFI partition, so it can start and boot from there. Insert Again, make sure here that you are on the correct drive. Yes, I'm executing the action. And it has formatted the thing here as MKS. Make file system. FAT. It did it. So here, the boot partition for Proxmox is being initialized. For me, the command fits, of course. But for you, make sure that the third drive and the correct partition are selected here. And now just click on and action. And now the kernels, the Proxmox kernels have been copied onto it. So these things here have basically just been copied over. Now, something else is very important, a good tool, because in the Proxmox Boot Manager, in the Boot Tool, the old disk is still listed here, the one that's broken, the one I removed. It still shows up and needs to be removed. Status. Let me tidy things up a bit here. One moment. Proxmox Boot Tool status enter warning. For me, there are now 2 disks missing here because I've already been messing around for a while. For you, the disk that's broken will show up here as well. This disk is missing with the ID here 6C98DB75 and the disk 5D16 FDD-FDF. That one is missing too. So these are basically old remnants lying around. Of course, we don't want to have those there either, and we want to make sure it stays that way. So the entries will be removed, probably with the appropriate command here, nano, etc. Kernel, Proxmox, boot, copy ideas, paste, and I have to remember this one here. The 16FD-FD5, the 16FD-FD, that one is being removed. Control, enter, control. I'll check the status again. Now there's still a warning, namely the 6C98DB75 again in the etc. The kernel it's the one up here, 6C98DB75. Those are my 2 remnants that were in there. Proxmox Bluetooth status, and now everything is okay. Now only the 2 disks remain, so the NVMe and the SDE, those are still listed there. They have kernel 6.1.4 and kernel 7.0. And with that, everything is nice and tidy there. So I'm almost certain that it will already boot from this as well. And now the ZFS drive itself is not yet mirrored. So the OPNsense software that's installed is presently only on the SDE. If that fails now, I lose OPNsense. I also still need to set up a mirror for the ZFS partition here. And for that, just as we have done before, I need zpool status so I can retrieve this specific number here. That's the missing disk, basically the one that failed on me. Looking at the zpool status command, it is this specific one right here. And quite unfortunately, I can't copy it from ZFS here. I can see the number here, but I can't copy it from here. So I need the shell again for that. And then I have the number here and can copy it. Now I want to replace this number. That's it. You didn't see the ID disk at ID Micron. It's missing. It's broken. Everything is explained here again. And now I could say here, replace pool. This one should be replaced. For me, it's the NVM0 N1 P3, which would be located right here. This specific target should be replaced. But for now, I'm going to list out all of the disks by ID first. I'd prefer to have the name of the disk there instead of the number. So listing STS-DSD isn't quite the right way to go about it. NVMe, this is the name by ID. I'll copy this for myself. And now I'll use something in Proxmox notes. The notes. And I'll paste this in for now. NVMe name. This is the name. Okay. I've made a quick note here to avoid spending hours searching later. Now, I'll put together the command, and this is the disk I'm replacing. I'll go back into the shell and type zpool status. And I have to put together the replace command. This is the one I want to replace. Once again, copy down the note for the faulty storage disk. Okay, and the replace command is built out of this element and this other one here, and not attach, replace. I'll grab this, copy this command here, edit, and paste it in here. And 62, that has to go into this command. I'll copy that for myself. That's the actual broken disk on my end. The other one was some random stupid number, because they also don't have the number that's listed on the website. And then it should be replaced with this NVMe, the device disk by ID path. NVMe-P3, that is most likely exactly how the command needs to be formatted. I'll check it down here, part 3. That's how it needs to look. Part 3, disk by it. That's correct. Let's check again. Yeah, it's not quite that simple with ID disk. With ID is correct, and that's part 3. And now the pool should finally work. So the command should work now. Okay, and now I'll copy it and hope that it works like this. Copy, then I'll go into the shell here, paste it in zpool, replace rpool, replace the broken disk number, the one you didn't see, with the new disk, def, disk by ID, NVMe, blah, 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 partition 3, and action. He's definitely doing something. ZFS, double click, he's replacing right here. He's doing the replacement, and here I can reload 64, 80, now it's almost done. And action. The disk was successfully replaced. Now, this rpool mirror is currently made up of dev disk by ID, specifically the Micron drive, which I'm about to pull out as well, and the disk by IDE NVMe. I hope you now understand what I mean here. If not, really rewind back and forth. Well, I do think it's understandable. If I reload now, then this mirror is now finished. It's now fine and is now online. I now have an air pool. I've now replaced a broken disk. And if I shut it down now comes the ultimate test. I'm going to shut the box down now, then I'll remove this SATA, the broken one, or the one that's still working, and then I'll start up only from the new NVMe. So, since I've been fiddling with the PCI Express slots again, my GUI isn't loading now. That means my network card has slipped back down to ENP6S0. I have to change that first in my shell. There at the monitor, at the server, I've done that now. Let's take a look. And now it's loading as well. And now we see there's only the SSD left here. This is also ZFS though. This is a 480, this is a 1 terabyte, this is a 3 terabytes and a 3 terabytes. This is regular storage. And now the server is only running from the NVMe 0 and 1. It's running here, it's working. We can also check the updates, refresh. So replacing the drive worked. So both the boot partition and the EFI partition, everything is working. Otherwise it wouldn't be here now, otherwise it wouldn't have started. Because this other one, this Micron, is no longer here. It's not here anymore, I removed it. It's just lying around now, but it's still in the ZFS pool. That's why it says degraded here. In my specific case, I now only want to have one NVMe drive in the server to act as the system drive. Because the main problem with my motherboard is that it's a high performance server motherboard. So if I plug in 2 NVMe's now, which I've already tested, then 2 of the onboard SATA ports are disabled. The Asus B550 Plus disables 2 SATA ports if you fully populate all the available slots. That's crap, if I may say so, but there's absolutely nothing I can do about it. That's why I'm only using one NVMe, but of course I also want to get rid of that old disk. So I have to detach it. I have to remove it, otherwise my pool will always be reported as unhealthy. So then I can use disk by ID here, of course, disk by ID for detaching. But if I want, I can also use the number here. Yes, for detaching. Of course, I also have a command for that here. Zpool detach rpool. I'll copy that for myself. I'll put it back into my notes here. I want to keep things organized here. I've done all that. I'll delete this now. That's the command I need for this. Then I'll go into the shell. Next, we will run zpool status. Now that is our mirror setup. That's the broken disk that's missing. It shows more here, so yes, as disk by ID. And I can copy it here just like that. Copy disk by ID part 3. And here are my notes for the animals. And then I basically have the command complete here. Let's copy this into the shell and remove this disk. So, how do I remove a hard drive from a ZFS pool? That is the question being answered here. And if I do this now, then the disk has been successfully removed. ZFS. As you can see, now the pool is green again, it is back online and fully functional, and there's only one disk left. And the command etas works the same way. So simply run your etas command, zpool etas rpool. This is now fully coordinated right here. I'll copy this first and then go into my notes, into the note edit section. We'll leave the touch for now, etas. And here it is basically. Checking the current Z status. Suppose that I would like to add a disk now. The musician truly knows where I added. I'll then take this name. That's included in the rpool. According to my current notes, this is basically the source here. And this is the target. And that essentially means that what we are doing here is zpool, please take this pool drive and expand its capacity with this drive to with the partition, add the partition labeled as SD3 into this pool. And then partition 3 from the source will be mirrored and synchronized over to partition 3 on the target. I'll edit again. I've copied this here. For that, I have a second tab open here, and again in the shell, I run zpool status. That's my source. I copy it with a right click, then I paste it here into my notes. I just need the name. Just insert the name disk by ID. NVMe, pen, whatever, you know what I mean? Tralala, partition 3 is supposed to be mirrored onto /dev/SDE3. Attach, again, it's the same here. Since that's the system drive, it would only work now with this attach command. Partition 3. So let's just stay here in this editor because it's actually quite convenient for this. I'll save this once. I have to do exactly the same thing here again. First SG disk, that's then NVMe 0N1. If I now plug in my second NVMe drive, then the source is 0N1 and the target will be 1N1. With this command right here, it is the exact same process as before. create that on the 1N1, then format partition 2 on partition 1, 1N1 P2, and initialize the boot partition on the 1N1 P2 using the boot tool. And then we can now save the boot tool status again. For now, since I'm organizing, it looks like crap. It doesn't make any line breaks here. That's annoying. This way is better. Here, the commands that need to run are saved, which is important now. I removed a SATA SSD, so now there's only this one ZFS disk left in here. Did you see this one, dev by ID? The NVMe is still in here, and in the boot tool, of course, the SATA is listed. So shell, just like before, boot tool status, warning, you saw it, it's listed there, but it's no longer present. That's the 3C47. That's the command. Nano, ECC kernel, Proxmox boot UIDs, and now I'll put that in here, insert it. And now I'll show you which one it was. Control X, that's the 9105, that one is being removed. Control O, done, Control X, boot tool status, and it's configured, UEFI version, you name it, yada yada. Now I'll add the other NVMe, then it's the same process all over again. I'll attach the disk now, and again my network card gets messed up. I have to set it up again. I'll do that now. I'll take care of that. Shut down. So I've now plugged in a second NVMe. It's blank. And once again, it changed the numbering of my network card. It turned the ENP6S0 into ENP7S0. I had to change that manually again just to get access here at all. And then there's another important note. It has now moved the previous NVMe 0N1 down and turned it into 1N1. And the new empty one is now 0N1. That means my commands change again. And that's why it's so important to follow this disk by ID approach. So that scripts, and as I did, everything is done by disk ID and not by device number, because that can change. So let's go back to the note, because now it says 111 here, of course. Of course, I did that wrong. I didn't expect it to change that, so I'll change it back. The new disk that I just inserted has taken the number 01, and the old disk has moved down. It slides to 111 or slides up, so do all 011 need to be remembered here again. So that I pick the right disk here, I would have used this ID now. Because that's a unique disk ID, I can of course use it for these commands up here. Dev disk with ID, and then I can execute the commands just the same. You can do it however you like. You just shouldn't get confused. So now I've remembered 0101 0101. Yeah, okay. Check again here in the OK that you're saving it to the disk. That's the 0 in 1. That one is empty. That's the one I want to blast onto now, and that's the one. In 1, also, with the attach, with the add command, of course I first have to scrub the boot partition, the partition table, and everything on it. So I'll start here again in the notes. I'll go into the shell here, do this, go into the notes and say sgdisk-rdev-target is 0N1. The target 0N1 should have the same partitioning setup as the source drive 1N1. Disk 0N1 should be created and partitioned just like 1. I'll add that here. Action has been done. Now I'll take a look here. Disk, boom, the 0N1 now has the 3 partitions. That's exactly how it should be. I'll take my notes again and say, generate a unique ID for this drive. 0N1 action has been done. Boot tool format, format partition 2 on 0N1 as EFI boot start, whatever, drive, do that, done. And then now copy Proxmox kernel and initialize the boot drive, copy, paste to 0N1 partition 2, action, copied, kernels are copied. And now zpool attach rpool def disk by ID. Let's take that as a reference, and now I want to change it. Now I'm going to do disk by ID again, and first get the disk by ID. Where is the command? Of course, we can find it here. listdisk ls-lh dev disk by ID. We'll copy that command. That's how we find out the disk by ID, so the ID of the disk. Enter. And here we have, up top somewhere is NVMe 0, N1 is the new one, and 1N1 is the old one. The 804 is the old one. Yes, that's the 804. We can also check again under disks, right? We need 804 and 690, so let's check 804, 690 is this one here. The disk by ID is the 690. I'll copy this whole construct here. Copy. I'll go in here to the notes into my command, edit it and say here dev, copy this for me. Disk by ID. Insert that in between. And then my command looks like this. Add to the rpool with this ID 804, the disk with the ID 690. part 3. And okay, if I copy this now, I've done the partitioning, I've generated a unique ID, I've formatted the boot partition or the EFI partition, and I've put the Proxmox kernel on it. And now I attach the new drive to the pool, add it, hold down Ctrl+C, paste. And now it's already copying this stuff. Up there you can see that it's already copying. If I reload now, it's already done. You can already see that the copying process was much faster this time than before. So now I've added a disk. The problem now, however, is that with my motherboard, since I have 2 disks in the NVMe slots, SATA port 5 and SATA port 6 are disabled on this motherboard. I can't use them, so they're of no use to me. So I'll just remove them again. But it works. I've now basically expanded this pool and added a mirror drive. Now I could wipe the drive again since it's a fresh new drive, but actually I don't have to do that. I'm not going to wipe the disk, I'll just take it out and set it aside. That way I can just reinstall it later and everything will already be set up. So I've now removed the disk, packed it up, and it's there for emergencies. If Boxbox causes any problems here, I'll just put it back in. And now if you look here, go to Z status, you can see that something is missing here, so I'll remove the drive now. Copy the data with dev up to part 3. Now I'll go back to my notes, remove the drive, and check which command is used for detaching. Yes, somewhere in the poetic replays, detach is the command for detaching, and it says to copy with it. Here, the drive is still attached, so I'll remove the drive from the air pool. That's what it's called, pool. Here, I remove my pool, copy this drive from the air pool, and now if we check again, FSR air pool is not available. It's degraded. I want it green. So I throw the thing out, insert it, action, ZFS, green, online. The pool is healthy, the pool is fine. But now the pool consists of a single drive with no redundancy, because where would it magically get the data from if something goes wrong here? With this operating system here, it's not that important. This isn't a long-term data archive storage where data blocks might just go bad over time. Usually, we have fewer problems with these drives developing such errors. I've never experienced it myself. I've never heard of something like that happening. No idea why everyone is making such a fuss about it. I can't imagine that any of you have a server at home that's so damn important. Like the servers at NASA or Elon's AI servers. Honestly, I just can't imagine it. Still, ZFS is a great thing if you know how it works. I hope this helped shed a little light on the subject for you. With an operating system drive, you have to be careful. When determining the drive designation, the numbers. And you have to be careful with everything, so you don't accidentally run commands on the wrong drives, because there are commands that will say, nope, I can't do that, it's in use, or something like that. But in the Linux world, there are also plenty of commands that just say, screw it. If you press enter, then it will just do it, and then it does it. And if, for example, you enter something like format C, it doesn't care. If you're unlucky, it'll just do it. Then it destroys your disk, your data, everything. So you really have to be extremely careful. That's why I wrote this article. I spent ages working on this crap. This article here, so that everything is in the right order, so that it's at least somewhat understandable. Don't mess up your drives. If you want to try something like this, do it on a test system or something to understand it better. So what else is there? Now that I've freed up my 2 SATA ports, I'm going to shut down here now. I'll check ZFS again. Everything is fine. Then Proxmox Boot Tool. I really don't feel like clicking around here for hours now. Boot Tool, where is it? Boot Tool status. Look, the disk is still in there, of course. The 997B is missing. Boot Tool status. I have that somewhere here too. Up here. Of course, I still want to remove the UUID from there. Was that 997B? There, the 997B is out. There's only one drive left. And everything is great since now I have my SATA ports 5 and 6 freed up. I've freed them up because I only have one NVMe plugged in, since unfortunately my motherboard can't handle it when everything is populated. SATA ports 5 and 6 work, but since I still have 24 terabyte drives, I'll leave it so that I only have one drive in the operating system here. But I have a spare drive on hand, so shut down like this. And now I've started it up again, and now I've connected SATA 5 and 6, and now I have my 4 terabyte. Disks, my 500 gigabytes ZFS pool. Here I sacrificed 500 gigabytes, but I wanted redundancy, and my 3 terabytes ZFS pool, which basically acts as a backup host here. And the 4 TB I still have now, and I can install Proxmox backup server here. And everything I have in my internet PBS storage, I can download and synchronize here. And with that, this Proxmox is now set up for me for the time being, so I can actually do something with it. Yeah, I quite like it this way. I still need to mount one of the ZFS mirrors here, ZFS 4 terabytes. I still need to mount it here, and then I can use everything here perfectly. Great. I really love it. And now I can also set up my OPNsense here. So, where is the hardware located? It's running on local ZFS. Local ZFS, that's not where it's supposed to be. It should be on the VM storage. I've made a backup there. Remove it. 300. Let's purge everything for now. Protection mode options. Remove protection for 300. Remove. And I have a backup here on ZFS. And there's the OPNsense, need, set, ISO backups, OPNsense and restore. And that's the 300, and it should go on the VM storage. Here on the 500 drive, which is made up of a 1000 gigabyte and a 480 combined as ZFS1 or a mirror, and that's where it should go. And now the thing is being restored there, and it's actually pretty quick. And then nothing will be left on my single NVMe, so it won't be excessively stressed. Only Proxmox itself will be running on it. And then I won't have any problems there either. At least not for the next few years with any failure issues. Start, protection is yes, and the next cloud. Protection is also yes for the next cloud. Why did he think that is starting? And we'll start the next cloud as well, since we're at it. And then it will be running. So now I'd like to address a comment, or actually several comments. I install my services in VMs. Why do you notice that? I don't have that many services. There aren't actually that many different services that I need to use containers here simply for the purpose of achieving faster startup times. The next cloud just took about 5 or 6 full seconds to start. I don't need my machines to start any faster. I really want to have a complete operating system in my next cloud here. I want this next cloud the way I want, from one Proxmox to another, no matter which version it has. I also want to be able to start the next cloud on another KVM system without Proxmox. I want the next cloud to have its own operating system so that it is self-contained and has everything it needs to work. I don't use containers, but I'm not advising against them. But I don't use containers because for me containers have too many disadvantages for their advantages to really make up for them. They are very, very small, lightweight, and start up extremely quickly. That's true. But if the Proxmox host has a problem, then your container has the same problem. If something from the container breaks through to the Proxmox host, then your Proxmox host has the same problem as your container. I don't want containers to mess around with any services on the mothership, because they need its data, its files, its environment. Every service, every system that is installed here on my Proxmox has its own mothership, its own software base, its own operating system, and yes, it is encapsulated. If something goes haywire inside this Nextcloud VM, then it's limited to this Nextcloud VM and doesn't break out on me. If my Proxmox breaks down, I can simply restore this VM wherever I want. But if everything is on this host, for me, those few megabytes, even a few gigabytes, really don't bother me at all. So anyone who wants to use containers is welcome to do so. It's not a problem. Everyone can do as they like. But I don't do it that way. I don't want to do it that way, and I don't for my clients either. The people who get this from me need to understand it reasonably well, at least to a certain extent. They need to understand it in a visual way on a human level, because they aren't all IT experts. And the question, why do you do it that way? That's totally legitimate. But comments like, that's not how you do it. Man, just do it however you want, dude. For all I care, ride your bike backwards. I really don't care at all. I don't care. Everyone should do as they like. I do it this way, and that's why it's not wrong. And yeah, that's just what I wanted to say. Everyone can do as they please. So everything's going well for me. I'm going to head down here now. Today, well, yesterday I picked cherries, sweet cherries. And today I made vanilla cherry jam from them. It's cooling down right now. And then I can have some, eat cherry jam. And then I got B-grade asparagus, 1 kilo. And now I'm going to make asparagus soup. Then it gets peeled, and then everything, the trimmings, gets boiled down exactly. And then a nice creamy asparagus soup is made. Alright, I wish you all the best. Here's the article, you can check it out if you feel like it.